Welcome back to Easy Chemistry by Venla. Today is the continuation of the NTPC previous year question paper. Next question. Which of the factors does not explain the acidity of alpha H in the species? Asking the question is does not explain. This is the given one. Minus I effect of the ester oxygen. Presence of second strongly electron donating group, second position of the ester. Resonance stabilization resulting in anion. Presence of second strongly electron withdrawing group at position 2 of the ester. Yes, this is the electron withdrawing group. And also here resonance stabilization also present. Here they given the minus I effect of the ester oxygen, but here they given the donating. So here our question is does not explain. So correct option is second one. Next question. Identify the example of an ATE complex. First of all, ATE complex generally formed by an Lewis base donate electron pair to electron deficient Lewis acid, producing anionic higher coordinating species. That is the ATE. Here in the first option, methyl borane reaction with methyl lithium. Here methyl borane is electron deficient and Lewis acid. Here methyl lithium is Lewis base. It is a nucleophile. What is the product here? Lithium plus tetramethyl borane. Here BX4, this one, BX4, this is the borate complex. See here ATE. So correct option is methyl lithium. Why other options are incorrect? In second option, nitro substituted carboxylic acid, no higher coordinate anionic central atom. No higher coordinate anionic central atom. So that is why second option incorrect. Next, third option. Here they given the zwitterionic or betaine. This type of structure not an 8 complex. So this is also incorrect. Next, last option. Here it is the sulfonate containing compound. It is a ionic sulfonate, but not the characteristic of Lewis acid. Here ATE is present, but not the characteristic of Lewis acid and base ATE. So that is why this is also incorrect. Correct option is first one. Next question. Consider the following reaction. Here they given the reaction. Which reagent brings about this reaction? You have to find out the reagent here. Here you can see this is the inversion configuration of SN2 type. Here first one I am taking RCl. Here chlorine and here also chlorine, but here it is a, they given the wedge and dashed positions. So RCl, Ag2O and water, it forms the ROH. At the same time, ROH reaction with PCl5, it forms RCl. So this is the inversion reaction. So I am using here reagents are this one, Ag2O, water and PCl5. So this is the correct option. For the reaction in the presence of piperidine, consider the following statements. Here aldehyde group is present. Here diethyl, malanoate, and this one salicyl aldehyde. This reaction with in the presence of piperidine. So here the statements: deprotonation of activated methylene by base gives carbanion that is stabilized by resonance via enolate ion. Yes, this is absolutely correct because here intermediate is the carbanion. This is the Knoevenagel reaction. Knoevenagel condensation reaction. What is that Knoevenagel condensation? Active methylene compound and aldehyde or ketone and base. Here actually base, here it is piperidine is the base. Here aldehyde is present but not ketone. See the second option. This is followed by the electrophilic attack on carbonyl of the ketone by the enolate ion. Not ketone. This is aldehyde. CHO group is present now. So that is why aldehyde is present. So second option, second statement is the incorrect. First statement is the correct. So see the options here. First option is the correct one. Next question. Consider the following statements. The compound they given the phenyl and this is the conjugated compound gives only this one when treated with HCl. See phenyl, this conjugated compound reaction with HCl. It forms the phenyl double bond here CH, and CH3. Here proton is added here and negative part this one in the conjugated double bond. So that is why this is the clear product. So see the option here, true. It is only product that has double bond conjugation with ring results from attack that place the proton at the end of the conjugated system. This proton at the end of the conjugated system and formation of carbocation stabilized by the resonance. Here carbocation, see this one. Here positive charge and this one is stabilized by resonance. This is the resonance. So correct option is first one is the correct one. Consider the following reaction scheme. They given the reaction and you have to find out the intermediate and final product. Here they given the this one alkyne and alkene double bond. Both undergo intramolecular cyclization. If you see this reagent, you have to find out this one is a radical cyclization and it forms the 5-member ring. So this bond like this. Check the options. See this one, no, and this one there is no ring present, so this is also wrong option. And this one here this another cyclization also present, so this is incorrect. So finally check this one. See this one, 5-member ring indene is present, indene type structure R1 and R2. So you can easily eliminate the above 3 options. You can easily find out the fourth option is the correct one. Next check the another one. Here in this hydrogen is replaces this one. So this is the correct one. So correct option is Fourth option is the correct one. Next question. Select the structure with chiral center. Whenever you see the chiral center, you have to remember this point. Carbon bonded to 4 different groups and also mirror image not present. See, check the options now. See, first option, mirror image present, so incorrect. See, here this one is the chiral center. Here 4 are the different groups. Then, so this is the correct option. See, next one. This is also incorrect. Not present the 4 different groups. Here also same, mirror image is present. So this is also incorrect. Correct option is the second one. Next question. Select the molecule that exists as a geometric isomer. Question is geometric isomer. 1, 1 dibromo 1 butene. Butene means how many carbons? 4 carbons. 1 butene, so double bond here. 1, 1 dibromo. Here bromo and here bromo. See, is it possible for geometric isomer? No. Next, 4 methyl 2 pentene. Pentene how many carbons? 5 carbons. Pentene means 2 pentene. Second carbon is double bond and fourth one is methyl. So this is the bond. Here it forms the EZ isomer. Next, 3 heptene. How many carbons? Heptene means 7. 3 heptene. 1, 2, 3. 3 heptene. Here it forms the geometrical isomer. This is the double bond and it forms the geometrical isomer. Next, 1 decene. This is also not possible for geometric isomer because double bond is in first carbon. So this is incorrect. Correct option is third one is the correct one. This is also correct option because it forms the EZ isomer. This one also correct one. Correct option is this one and this one. Next question. Identify the structure with R configuration. Here I am giving the excellent trick for you. When the hydrogen is in vertical position, hydrogen is in vertical position. This is vertical. If it is in vertical, this is clockwise R configuration and this is S configuration, anti-clockwise. If otherwise horizontal, this way or this is horizontal. When it is in horizontal, simply reverse. Clockwise is S, anti-clockwise is R. Here simply you can remember V R, this one clockwise. VRC. I think VRC is a well-known word because of in Nellore VRC center is the famous. So that is why simple trick is VRC. If it is vertical, that is R configuration and it is clockwise. So check the first option. This is the chiral center because 4 different carbons are present. So which one you give first priority? Nitrogen. Second one, this one. Third, here. And it is 4. Check here. This is like this because hydrogen is in vertical position. So what is this? Clockwise. So it is R configuration. Our question is R configuration. So first option is the correct one. Next, we can check the other options also. This is second option. We can check second option also. See, this is the chiral center. So first priority, this one, and the second priority here. Third, this one. Fourth priority, like this. Yes, anti-clockwise direction. Why I am giving here 1 and 2 and 3. Why don't I am giving this one 1, this one 2? See, first check the first atom. See, first atom is carbon. All are same. Next one is here oxygen, here carbon, here hydrogen. So, which one is highest atomic number? Oxygen. So, I am giving first priority this one. Next, see these two. Here, first one is carbon, same. So, next one is here carbon, but here hydrogen is present. So, I am priority giving the carbon. So, this is the second. This is the third one. So, finally, hydrogen is there. So, it is S configuration. Next option. Here, already given the hydrogen is in vertical position. Next, here first priority, which one? Bromine. Next, this one. Here carbon is there, so third, this one. S configuration, anti-clockwise direction. Next option, here iodine is present. So first priority, this is second priority, and this is third, like this. Anti-clockwise direction, yes. So you can simply answer in this way. Next question, select odd one from the following options. See, check the 4 options. I am given one simple trick. Write OH and left OH. If right OH is present, DL configuration. So, if it is right, D. L configuration. See, left is L, starting letter, and it is L. Both LL. You can simply remember like this. Now, check the option. Here, see, this one is OH, right side. See, this one also OH, right side. This one OH. But here, it is H. Left side is OH is present. But above 3 options are OH is present, right side. But here is present, left side. So, correct option is this one. Odd one is the fourth one is the correct option. So, this is the end of the today's session. Further questions we will continue in next section. Thanks for watching.